welcome back to this channel, and then we'll be looking at techniques for computing limits. We're going to be looking at limit of linear functions, limit laws, and then limit of polynomials and rational functions, other techniques for solving the limits, and then we're going to be looking at squeeze theorems. At the end of the modules, you will have been granted, you will be able to solve any questions on limits. Okay, so without further ado, let's go straight to the first part, limits of linear functions. Okay, and in that case now, imagine you have limit of f of x. If you have this as x tends to a, okay, so limit of linear function is done by direct substitutions. This is your limit of f of x as x tends to a. So in that case now, this is your function f of x. So you just substitute anywhere you see x, you place your a there, and that will give you what? F of what? F of a. And that's that on limit of linear functions. If your linear function, for example, your linear function is x plus b as x tends to a. Okay, what this one is just telling you that this is your functions. Okay, it just direct substitutions, and that will be equal to m a plus what? Plus b. Evaluate the following limits. We have limit of f of x as x tends to a, where your f of x is what? Is this. So this is just direct substitutions, and that will be equal to limits as x tends to a. Your f of x is this. So what you just do is just to substitute number 2a minus what? Minus 7. And that finished that. The b part, limit of g of x. Limit of g of x as x tends to 2. Okay, in this case now, your g of x is 6. Your g tends to 2. So in this case now, limit of a constant is that constant. Limit of a constant is that constant. Limit laws. Okay, if assuming limit of f of x as x tends to a and limit of g of x as x tends to a exist, following properties hold, where c is a real number and your m and n, they are integers, they are greater than 0. Your m and n is greater than 0, which means they are positive integers. Okay, so we have the list of the rules. The first one is a limit of sum of functions, okay, which will be equal to limit of what? Each of those functions as x tends to what? As x tends to a. Difference of functions, limit of difference of functions as x tends to a will be equal to limit of each of those functions. Limit of f of x as x tends to a minus what? Limit of g of x as x tends to a. Okay, then the third one, we have limit of f of x as x tends to a, and you have a constant. What this one is saying is that the constant will be taken out of that limit, and you have what? You have c, limit of f of x as x tends to a. Then limit of a product of two functions or even three functions is going to be what? It's going to be as x tends to a, it's going to be limit of f of x as x tends to a, close that, times limit of g of x as x tends to a. Okay, so limit of a product is equal to what? Limit of each of those functions, then multiply together. Limit of a quotient functions, okay, limit as x tends to a of a quotient function. Okay, it's going to be limit of the numerator, limit of the denominator for that function as that function tends to as x tends to a. Okay, and then note g, the denominator must not be equal to what? Must not be equal to 0. And finally, on the list of the laws is the limit of f of x to power n. Okay, and that will be equal to what? As x tends to a, and that will be equal to everything, open your bracket, limit of f of x as x tends to power what? To power n. Suppose limit of f of x as x tends to 2 is 4. Limit of g of x as x tends to 2 is 5. And limit of h of x as x tends to 2 is 8. Use the limit law to compute each limit. Okay, the first one, we have a limit of a quotient function. And the numerator is a difference of function, h of x minus g of x. This is going to be what? Limits of f of x minus g of x. You have to open your bracket here and close it here, over as x tends to 2, limits as x tends to 2 of h of x. Okay, so you're now having now limits of difference of function, and that will be equal to all over limits as x tends to 2 h of x. Then we can begin to make our substitution. We have a value for this, limit of f of x as x tends to 2. We have a value for that, that's 4. And then we have value for limit of g of x as x tends to 2, that's 5. And also for h of x as x tends to 2, that's 8. So that's giving us minus 1 over 8. The b part, we have limits of your brackets open here, 6 times f of x g of x plus h of x. So this is going to be, we have a product of limits and we also have a sum. This 6 can come to the front here as x tends to 2 f of x g of x, then plus limits as x tends to 2 h of x. So in this case now, these are two products, so you can close it, open and close the brackets. So, and this will be equal to 6 into brackets, limits as x tends to 2 of a function f of x times limits as x tends to 2 g of x. Close your brackets, then plus this one. Then begin to make your substitutions. You have your f of x as 4 times g of x is 5. Close the brackets, then plus h of x is 8 plus 8. And that will be, this will be 20 times 6, 120 plus 8, that's 128. And don't forget, this 6 does not affect your h of x. It only affects f of x and g of x. The last one, the third one here, so it's going to be limits of g of x as x tends to 2. You can close your brackets, open and close your bracket to power 3. And we have the value for g of x. Our g of x is 5. So that's 5 to power 3. And that's 125. So that's that on these aspects. I want to thank you for watching this video. New on the channel and you're yet to subscribe, please click on the watermarks on the video and subscribe. Don't stop there. Click on like button and begin to type your comments. Okay. Finally, share the links of this video on all your social media platforms. Thank you for doing that.